so this is the full code for that Fibonacci prover peer-to-peer that we saw in the previous video. First, we import a circuit that's been compiled by the SP1 prover, which contains the actual Fibonacci code. That's in in their repo or in a file. It's very easy to find. It's basically just the Fibonacci function inside of a Rust program. Here's our app. So we've got a request response protocol here, very simple. We send this to ourselves to ask a peer to produce a proof for us. We send this remotely to the peer's Fibonacci program. We get this response back locally, and then we get a proof in bytes in the message blob from the remote prover. Quick function to basically use the SP1 prover to call this ELF, run it, and basically serialize that proof. Then we have the core sort of event loop down here. We just handle messages. We print this, you saw that. And in handle message, we just bring in the next message. We attempt to deserialize it to one of our protocol messages. If we get a local proof request, we basically take it from our local node, send it to a remote node with the part of the protocol that's for that. We get the proof back, hopefully. We verify the proof, and we read the result. And then we respond to our local requesting process. If we are a remote node that's receiving a request for a proof, the code's very simple. We just produce the proof and send it back in response. Now, of course, the logic that can be added on here is endless. More than just the Fibonacci sequence, you could prove arbitrary computation, and you can do arbitrary amounts of peer-to-peer work to coordinate, gatekeep, and break that process up in any way you see fit. So this has immense applications in financial tools, in games, social protocols. Lots of things are going to be built with this.